Welcome to our deep dive into the fascinating world of interstellar travel and the mysteries of Proxima Centauri. Just a cosmic hop, skip, and jump away at a mere 4 light-years, Proxima Centauri is our closest stellar neighbor, a red dwarf star harboring a planet in its habitable zone, Proxima Centauri b. Today, we'll explore the challenges, breakthroughs, and future possibilities of reaching this star system. Buckle up, space fans, because we're about to embark on an epic journey to the unknown. So, why Proxima Centauri? Well, in the vast cosmic ocean, it's our next-door neighbor. This red dwarf star system holds a planet, Proxima Centauri b, in its habitable zone. That means it could potentially have liquid water on its surface, the key ingredient for life as we know it. But interstellar travel, even to our closest stellar neighbor, is no walk in the park. With our current technology, it would take tens of thousands of years to reach Proxima Centauri. That's why scientists and engineers are hard at work exploring new propulsion systems that could dramatically reduce travel time, like fusion rockets, antimatter engines, and even warp drive. All right, let's talk distances. Proxima Centauri, our nearest stellar neighbor, sits 4.24 light-years away. A single light-year is the distance light travels in a year, clocking in at a mind-blowing 5.88 trillion miles. If we hopped aboard the space shuttle, it would take us a staggering 165,000 years to reach Proxima Centauri. Clearly, we need a serious upgrade if we're going to make this trip in our lifetime. The sheer amount of energy required for interstellar travel is astronomical, literally. We're talking about harnessing energy on a scale we've never even dreamed of before. But hey, we humans are an ingenious bunch. We've overcome seemingly insurmountable challenges before, from splitting the atom to landing on the moon. Now let's dive into some of the cutting-edge technology that could make interstellar travel a reality. One of the most promising concepts is laser propulsion, specifically something called a GRS-scale spacecraft. This idea involves a giant, Earth-based laser array that would propel a spacecraft to a significant fraction of the speed of light. Imagine a spacecraft with a giant reflective sail catching a powerful beam of light from Earth. With a GRS-scale spacecraft, we could potentially reach Proxima Centauri in a matter of decades, not millennia. Of course, this technology is still very much in its theoretical stages, and there are significant engineering hurdles to overcome. But when the prize is interstellar travel and the possibility of discovering alien life, well, let's just say we're not afraid of a little challenge. Now, let's talk money. The estimated cost of a mission to Proxima Centauri is a cool $100 billion. The Apollo program, which landed humans on the moon, cost about $150 billion in today's dollars, and the International Space Station has cost upwards of $150 billion over its lifetime. So, while $100 billion for a mission to Proxima Centauri might seem like a lot, it's actually on par with some of humanity's most ambitious scientific endeavors. Funding such an ambitious project would require a global effort, with nations around the world pooling their resources and expertise. Proxima Centauri b. Here's where things get really interesting. This exoplanet has captured the imagination of scientists and space enthusiasts alike. This planet sits right smack in the middle of Proxima Centauri's habitable zone, often referred to as the Goldilocks zone. That means it's in the sweet spot where temperatures are just right for liquid water to exist on the surface, a crucial ingredient for life as we know it. Now, before we get ahead of ourselves and start picturing little green aliens, we need to be cautious. The conditions on Proxima Centauri b are far from perfect. Proxima Centauri b is a lot closer to its star than we are to the Sun, likely tidally locked, with one side perpetually facing the star and the other shrouded in eternal darkness. This creates extreme temperature differences. And because Proxima Centauri is a red dwarf star, it's known to unleash powerful flares, which could bathe the planet in harmful radiation. This radiation could strip away the atmosphere, making it less hospitable. But even with these challenges, the possibility of finding life on Proxima Centauri b is too tantalizing to ignore. The search for life beyond Earth continues, and Proxima Centauri b remains one of our most intriguing targets. Traditionally, astronomers have searched for life on other planets by looking for biosignatures, chemical fingerprints in a planet's atmosphere that could indicate the presence of life. These biosignatures include gases like oxygen, methane, and ozone, which on Earth are produced by living organisms. By studying the light that passes through a planet's atmosphere, scientists can identify these chemical fingerprints and infer the potential for life. However, when it comes to Proxima Centauri b, our traditional methods of detecting biosignatures might not cut it. The planet's proximity to its host star presents unique challenges that make it difficult to apply these conventional techniques effectively. Proxima b is incredibly faint compared to its host star, making it very difficult to observe its atmosphere directly. The brightness of Proxima Centauri overwhelms the faint light from the planet, complicating efforts to detect any potential biosignatures. Moreover, the intense radiation from Proxima Centauri could alter the chemical composition of the planet's atmosphere, making it difficult to distinguish between biosignatures produced by life and those created by abiotic processes. This radiation can strip away atmospheric gases or create false positives, further complicating the search for life. Scientists are developing new and innovative ways to search for life on Proxima Centauri b, such as looking for subtle variations in the planet's light as it orbits its star. These variations can provide clues about the planet's atmosphere and surface conditions, offering new avenues for detecting signs of life. Another promising approach is to search for technosignatures, signs of advanced technology such as radio signals or large-scale structures that could indicate the presence of an alien civilization. By expanding our search to include these indicators, we open up new possibilities for discovering life beyond our solar system. We're living in a golden age of exoplanet discovery. Thanks to powerful telescopes like Kepler and TESS, we've now confirmed the existence of over 5,000 planets orbiting other stars in our galaxy. And that's just the tip of the cosmic iceberg. Astronomers estimate that there are likely billions of planets in our galaxy alone. The search for exoplanets is driven by the fundamental human desire to explore the unknown and answer the age-old question, are we alone? And with each new discovery, we come one step closer to finding out. Speaking of powerful telescopes, let's talk about the James Webb Space Telescope, or JWST for short. This incredible feat of engineering is already revolutionizing our understanding of the universe, and it's only been operational for a short time. Unlike its predecessor, the Hubble Space Telescope, JWST observes the universe in infrared light. One of JWST's primary missions is to study the atmospheres of exoplanets in unprecedented detail. The discoveries made by JWST are not only advancing our understanding of the universe, but also inspiring the next generation of scientists and explorers. Okay, let's take a detour into the realm of science fiction. Or is it science fact? The lines between the two are often blurred, making it a fascinating topic to explore. One of the most enduring dreams of science fiction enthusiasts is warp drive, a technology that would allow us to travel faster than the speed of light by bending the fabric of space-time. Imagine the possibilities of exploring distant galaxies in a matter of days or even hours. While warp drive is still firmly in the realm of theoretical physics, some physicists believe it might not be as far-fetched as it sounds. Recent advancements in our understanding of the universe have opened up new avenues of thought. The idea is based on Einstein's theory of general relativity, which states that massive objects warp space-time. This warping could theoretically be harnessed to create a warp bubble, allowing faster-than-light travel. And then there's the search for extraterrestrial intelligence, or SETI. This ambitious project aims to answer one of humanity's oldest questions. Are we alone in the universe? For decades, scientists have been scanning the skies for radio signals or other signs of alien civilizations. The search is meticulous and requires patience, but the potential rewards are immeasurable. While we haven't made contact yet, the search continues, fueled by the belief that we can't be alone in this vast and ancient universe. The quest for knowledge and understanding drives us to keep looking, hoping that one day we might find a signal from another world. So what does the future hold for interstellar travel and the search for life beyond Earth? While we don't have a crystal ball, one thing is certain. The journey is just beginning. As our technology continues to advance, we can expect to discover even more exoplanets, some of which may be even more Earth-like than Proxima Centauri b. The exploration of exoplanets like Proxima Centauri b is not just about satisfying our curiosity. It's about understanding our place in the universe and the potential for life to exist elsewhere. It's about pushing the boundaries of human knowledge and inspiring future generations to reach for the stars. So, let's keep exploring, keep questioning, and keep dreaming of a future among the stars. Thank you for joining us on this journey through the cosmos. From the mind-boggling distances involved to the cutting-edge technology that could make it possible, we've explored the challenges and possibilities of interstellar travel to Proxima Centauri. Who knows what wonders await us out there among the stars? Don't forget to like, subscribe, and hit the bell icon for more fascinating explorations of our universe.